30% of spin. 1G. How's gravity treating you back there?
Wow.
In the previous clip, the spaceship is shown to produce artificial gravity. Because we know that the spaceship has a radius of 32 meters and spins at a rate of 5.6 revolutions per minute, we can calculate whether 5.6 revolutions per minute will produce 1 g of artificial gravity. Using the formula weight felt inside the spaceship equals radians per second squared times the radius of the spaceship divided by 9.8 meters per second squared, or g, we can calculate whether or not the spaceship's artificial gravity is realistic. 5.6 revolutions per minute is equivalent to 0.093 revolutions per second, which is also equivalent to 0.59 radians per second. When we plug radians per second and the radius of the spaceship, 32 meters, into the equation, we do indeed find that the weight inside the spaceship is 1 g. Therefore, the movie's artificial gravity found by spinning the spaceship is realistic.
The navigational hub has been completely destroyed. I think we can scratch our way to Edmund's planet. We let Gargantua pull us down close to her horizon, then a powered slingshot around, launching us towards Edmund's planet.
Prepare to detach.
What? No! No!
Newton's third law. You gotta leave something behind.
You told me we had enough resources for both of us.
We agreed, Amelia. 90%. Detach.
In Newton's third law, he describes the relationship between two forces in an interaction. Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. One force is the action force, while the other is called the reaction force. Both of these two forces are equal in strength and opposite in direction. In the previous clip, you can see how the action of the spaceship separating from the smaller spaceship caused a reaction to the larger spaceship, propelling both objects to increase their velocity with the direction. For example, consider a cannon and its ammo. The force on the cannonball inside the inside of the cannon barrel is opposite and equal to the force causing the cannon to recoil. As seen in the movie, the smaller ship broken from the larger ship are equally and oppositely propelled away from each other due to Newton's third law of motion, further adding speed to larger spacecraft and further excel towards the planet away from Gargantua.
Go, 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 go. 7 years per hour here. Let's make it count.
Hello, Rob?
I've waited years. How many years? By now it must be.
It's 23 years, 4 months, 8 days.
In the movie, when they return to their spaceship, their crewman says that it has taken them 23 years, 4 months, and 8 days to return, while Cooper, the main character, says he has been gone for 3.3 hours. To find out whether or not time could have been dilated this much, we use the equation relative time, or the time felt by the man not on Miller's planet, equals time felt on the planet divided by the square root of 1 minus the speed they are traveling divided by the speed of light squared. The time dilation is found by dividing 3.3 hours by the square root of 1 minus the speed the planet was traveling around the black hole, which was 55% the speed of light, or 3 times 10 to the 8th times 0.55 divided by the speed of light squared. This result is 3.95193, or approximately 4 hours. This means that time dilation was only about 14 or 15%, so there must have been another explanation for why time was dilated for another 24 years, and not 0.7 hours. Although not explained in the movie, time dilation could have been explained by the black hole pulling space-time, causing a stronger time dilation effect than the speed of the planet itself. Therefore, we cannot determine what caused such a dramatic time dilation effect in the movie Interstellar.
Where's the mountains?
Those aren't mountains. They're waves. Brand Doyle, back to the Ranger now. Manually overriding inside hatch.
In the movie Interstellar, the past clip where they experienced a huge tidal wave to their spaceship, many people, when watching the movie, thought that it was a tsunami because it was such a ginormous wave. The reason why it was not a tsunami is because the ocean would be swept back off the ocean's floor and then back into the tsunami. A tsunami is an ocean wave triggered by a large earthquake that occurs near or under the ocean. A tidal wave in the movie is the rise and fall of the sea caused by gravitational forces. But in the movie, the tidal force on the planet arising from the black hole which caused the tides. In Interstellar, Miller's planet is the equivalent of the Earth and Gargantua is the equivalent of the moon. Newton showed that the ocean tides are simply caused by differences in the gravitational pull of the moon and on opposite sides of the Earth. But in Miller's planet, the black hole Gargantua acts as the moon in this case to create tides and further creating the tidal wave in the movie. This is how big tidal waves are on Earth. And this is how big they were in Interstellar. The Lituya Bay mega tsunami is the largest tsunami ever recorded and is still half the size of the wave in the movie Interstellar. In reality, tidal waves are more of swelling of water, essentially a bulge of water, and not a large wave.